This is part 4 of section 4.2. We've talked about the exact values for quadrantal angles, where they are defined, and we know that sometimes we end up with 1 over 0, so they're not defined. But now we're going to calculate the exact function values of 3 common acute angles. We talk about a 30-degree angle, which is equivalent to pi over 6 in radians, a 45-degree angle, which is pi over 4 radians, and 60-degree angle, which is pi over 3 radians. And what we're going to be doing is we're going to be relating this to triangles, specifically right triangles, and using the Pythagorean theorem to calculate these. Okay. So let's look at what this would look like for a 45-degree angle. Okay, we would have a picture something like this. Okay. We know that a 45-degree angle bisects this quadrant because it would be half of a 90-degree angle. And the equation of this line that bisects these two quadrants is y is equal to x. Okay? So this means that we have a right triangle here. I know that this length is 1, so I could use the Pythagorean theorem to figure out what these are going to be if I knew x or y, and I don't right now. But we can see that it's definitely on this line, and we know that we're looking for this point that is on the unit circle, and that points on the unit circle have to satisfy x squared plus y squared equal to 1 by definition. So what I'm going to do is, since I know that my x and y have to be the same, I'm just going to substitute y equal x, or I could do x equals y, it doesn't matter. But if I make that substitution, I get x squared plus x squared is equal to 1. Therefore, 2x squared is equal to 1. And x squared is equal to 1/2. Now take the square root of both sides, and you get x is equal to plus or minus the square root of 1/2. And since I'm looking for the point that is here in the first quadrant, even though algebraically I get 2 answers, I'm really only interested in the positive answer here because my x value is not going to be negative in the first quadrant. So I'm mainly interested in x equal to the square root of 1/2. And that would be the square root of 1 over the square root of 2. And like we said, we rationalize these. And you get your x value is the square root of 2 over 2. So that means that this point right here, the one associated with a 45-degree angle, this is the point square root 2 over 2, square root 2 over 2. Since your x and your y values are the same, sine and cosine are the same. Okay? Now let's talk about a 60-degree angle and a 30-degree angle. And I'm going to remind you of some things from basic geometry here. Here I have an equilateral triangle. All my angles are 60 degrees. Each side is length 1. Why did I choose 1? Because I'm going to be putting this on the unit circle and doing some calculations in a second. Okay? Now, if I take this equilateral triangle and I drop an imaginary line from the top down to the bottom so that I make a right angle, that cuts this top angle into a 30-degree and a 30-degree angle. H is the height of the triangle, and it splits the bottom into 1/2 segments. And now right here, all we've done is we've taken that part off, and we're talking about this one little right angle. Now, how did they get this? Simply using the Pythagorean theorem. If I have a squared plus h squared equals 1 squared, and you do the calculations, you get your h value is the square root of 3 over 2. I'm not going to go through all that. I know you know how to do that. Okay? Now what we're about to do is we're going to take this what we call a 30, 60, 90 angle, and we're going to place it onto the unit circle. Okay, so if I do it like this, and I put the 60-degree angle right here, okay, this is your hypotenuse, it is the radius, it is 1. Now what we saw here is that when we have the angle of 60 degrees is made up by a 1, one side that's 1 and the other side is 1/2. So if I put that here, the 60-degree angle, the hypotenuse is 1, and here's the 1/2, and this is the height. Now we know that this would be our x value, this would be our y value, which is where these two values come from. So here, this means that sine of a 60-degree angle, or pi over 3, which remember, these are coterminal, just depending on whether you're talking in degrees or radians. Your sine value is the square root of 3 over 2. Your cosine value is 1/2. Now, if instead of writing it with a 60-degree angle here, we flipped the triangle around so that we have the 30-degree angle here, it's still the same triangle, so the lengths are still going to be the same. It's just a matter of orientation. This is 1 because it's our radius. In here, the 30-degree angle was made up from the sides that are 1 and then the square root of 3 over 2. So now this is my x value because of the way we have it oriented, and this is my y value because of the way we have it oriented. So basically what we've just shown here is that 30 and 60-degree angles have the same two numeric values, it's just your sine and your cosine are switched. So just in summary, this is what we have so far. We have our quadrantal angles with our associated x and y values. And then we found pi over 6, pi over 4, and pi over 3. Now remember what we said in the very beginning about having our symmetries, and we can use sort of like a rectangle image to get function values from in the other quadrants. And this is just an image where we do that, okay? Sorry, I have a lot going on here. When we know pi over 6 is square root 3 over 2, 1/2, and then we make the rectangle like this, and basically we have the same numeric values, but with the signs that are appropriate for the quadrant that you're in. So square root 3 over 2, 1/2, here your x values are negative, and your y value is positive. Here they're both negative. Here is opposite. And all we're doing here is using the symmetry for the three angles that we talked about to get their symmetric ones. And then what we can do is, since we know how to find our x and our y, we have all of these symmetric angles, and we know how to use our x value and our y values to find all 6 trig functions, we can create a chart that looks like this. Okay? These are our main function values. These are quadrantal angles, and these are the ones that we have calculated based on the triangles that we have. And this just go ahead and calculates your tangent, your cotangent, secant, and cosecant.